Now let's look at the Lewis bonding theory in the context of ionic bonds. And when we're looking at ionic bonds, we're going to look at the simplest metal and non-metal type of interaction. So electrons are going to go from the metal to the non-metal. So the metals lose electrons to form a cation, and the non-metal gains electrons to form an anion. And the way we're going to think about this is that the electrons that the cation lose go to the anion. So this would be an example of a redox reaction. One substance loses electrons and another substance gains them. The ionic bond results from the positive and negative attraction. Unlike charges attract one another. And there are two features to think about when we're thinking about this positive and negative attraction. The larger the charge, the stronger the attraction. So a positive 2 charge is going to be a stronger attraction than a positive 1. And the smaller the ion, the stronger the attraction. That is because the positive and negative attraction is very, very dependent on distance. So if we have small ions, that positive and negative charge can get closer together, and the closer they are to one another, the stronger that force is. Lewis theory allows us to predict the correct formulas of ionic compounds. And we can take a look at this. Let's look at how electrons are transferred and the ionic bond is formed when a sodium atom reacts with a sulfur atom. Now the first thing we want to do is write out our Lewis dot symbols for our atoms. Sodium is in our first column, so it has 1 valence electron. Sulfur is in the oxygen family, so it has 6 valence electrons. Now, sodium wants to lose an electron, and sulfur wants to gain. Sulfur has 2 spots. It needs 2 electrons to get the octet that is stable. And sodium can lose 1 electron at a time. So we need 2 sodium atoms, and 2 sodium atoms will give us 2 electrons. And those 2 electrons we can add to a sulfur atom to get our sulfide anion. So when we take a look at electrons transferring, we saw that we needed 2 sodiums for each sulfur. Because sulfur needed 2 electrons and each sodium had 1 electron to give. So when we look at electrons, we can use that to help us figure out the correct ratio of cation to anion in ionic compounds. So let's look at this and see if we can figure out or predict the compound that forms between calcium and chlorine. Here's the Lewis dot symbol for calcium. Calcium in the second column as an alkaline earth metal has 2 valence electrons. Chlorine as a halogen has 7. Each chlorine wants 1 electron, and calcium has 2 to give. Therefore, we need 2 chlorines to accept the 2 electrons that calcium wants to give away. Now, why does calcium want to give them away? When it loses these 2 electrons, it gets a stable noble gas configuration with no valence electrons. And when chlorine gains an electron, it also gets a stable noble gas configuration. So basically, to figure out the formula based on Lewis symbols, we draw out the symbols of each element and we see how many we need to give away and how many we need to gain. And then we have the correct ratio of gainers and losers so that all of our electrons are accounted for. Okay, so use the Lewis symbols to predict the formula of an ionic compound made from reacting a metal that has 2 valence electrons with a nonmetal that has 5 electrons. So using the technique that we just looked at, pause the slide and see if you can come up with the right answer. So let's look what we have. We have a metal with 2 valence electrons. So this wants to give away 2 electrons, and we have a nonmetal with 5 valence electrons. So this wants to gain 3 electrons. We need 3 more electrons to have an octet. So if we look at the least common multiple, or the least common denominator between 2 and 3, it's going to be 6. We're going to give a total of 6 electrons away, and we're going to gain a total of 6 electrons. So we'll need 3 metals and 2 nonmetals, so we can give away 6 electrons and gain 6 electrons. This number has to be equal. We've got to give away the exact number that we receive. So let's look what we have. Okay, so I'll take 2 electrons from here and give them to this guy. 1 electron from here, give them to this guy. So now we have our stable octet, and I've gained 3 electrons, so I have a total of -3 charge, and then I have 3 electrons left, which is exactly what this guy needs. And so I've used 3 metals and 2 nonmetals, so my formula is going to be M3X2.